Hello everyone, welcome back to our course on data structures and algorithms. In our last lesson, we introduced the variable type array. We reviewed how to create an array in the Java language, how to access elements in the array, and we briefly discussed how arrays are stored in memory and how they behave. And just by review, we like to use this picture here. The picture of picturing an array as a set of adjacent containers in the memory, and our variable, when we write a variable for an array, giving it a variable name, it points right to the front, and then this would be our variable name, like array bracket 0, array bracket 1, etc. Also remember that arrays have a set length that are made at creation. So in this array that I've drawn here, we've made the array of length 5. And I'm just indicating that with array.length and showing that it's equal to 5. And also, not only do you have to decide how big an array you want when you create it, you have to decide what type. So that's also another important limitation on arrays. Today I want to start talking about our first abstract data structure, and that's called a list. So we're going to be making a list. What makes this an abstract data structure is that it's defined based on how it behaves, not how it was created. So we could make a list with several different ways, but as long as it behaves like a list, it's a list. We're not concerned with how it's made, we're concerned with what it does, and that's what makes it an abstract data structure. In this lesson, we're going to be making a list using an array. And so let's talk about what we need a list to be able to do. Something is a list if it's like a shopping list, right? So we need to be able to add items to our list. So if we want to make a shopping list that we're going to go to the store and try and get all these things, we want to be able to add to that list, right? That's important. We also want to be able to access it or read it, right? Or else it's not going to do us any good when we get to the store if we can't pull out our list and look at it to make sure we got everything. Also, if I add something to my shopping list and then decide, actually I don't need it, I need to be able to remove from it, right? So we need to be able to remove from our list. And ideally it would be nice if we could also, search through our list. If we could look through it and find specific items that we might want or need. So we want to try and make something using an array that allows us to do those different things. We'll start with just the basic ones like adding and accessing and build from there. So how would we do this with an array? Well, right off the bat, we've got a problem. As you can see, I've created an array here of length 5, but nothing's in it. Once I create an array, I'm stuck with that size. Well, there's a pretty simple answer here, actually. Let's create an array big enough that that'll be more than enough room. And then let's keep a variable that keeps track of where we are in the array. So we could say make an array of integers, and I can have a variable such as size. So the variable size, when the list is created, we'll just start that at 0. And that tells me, yeah, I've got all these blank spaces in my array, but as long as size is pointing right here, indicating that I can only go 0 elements back in my array, then it works very well as a list. Then if I come in and I say, you know what, I'm going to add an integer to this list of integers, say the number 8. Well, then I'm simply going to increase size by 1, and I'll simply, what that's doing essentially is it's indicating that my list is now this long. And so I can see that I have an 8 here, and I don't care that I've got these empty cells back here because I'm not going to look at them anyway. They would probably just have zeros in them because that's the default value for an array. Alright, so we can keep adding to our list. So let's add another number. Let's add, say, like a -3. And then that would mean that we need to increase our size. And as you can see, it's really behaving very much so like a list. So now I'm at size 2. Let's add one more. Let's add a 4. And that'll bring our size up to 3. So how could we remove from this list? Well, we could remove from the back of our list very easily. So right now, our size variable is telling us that this is our list here. Well, if I simply change the size from 3 to 2, then I'm just going to move this back one space here. And essentially, I've removed the last element of my list. Because when we try and read the list, we're not going to allow any access beyond this mark that I've made with my arrow. So the fact there's a 4 there doesn't matter. It's essentially gone. Then let's say we want to add another number, this time not a 4, but a 5. And you can see that we've written over that 4 that was there. So, adding and removing from the back of our list is really quite simple. Okay, so what are we going to do when we run out of space, though? I mean, that is going to happen eventually, right? I mean, we have a couple options. We could make our array as big as an array is allowed to be, and then just keep adding to it. But that's pretty wasteful and just quite unnecessary. And it doesn't take that much coding for us to not have to start with an array that super big. So let's decide what we're going to do when we run out of space. I'm just going to fill this up, put like a 17 and maybe how about a 2 here. Okay, so right now we're currently at a size of 1, 2, 3, 4, 5. So let's say we've got a list of size 5. What are we going to do? Okay, so here's our methods that we want to use. I'm just going to clear that off so that I have room to draw over there. What will we do in this situation? Where we have a list, it's made with an array. We've already added as many elements as the length of the array allows. And now I want to add another one. Well, it's really not that hard. We're simply here. Array is a pointer. Okay? It is a reference, to be exact. This variable called array, and I of course could call it anything. I could call it my array or the array of my list or whatever you want. Well, it's pointing right there to the front of this block of memory, and then we access the different cells with bracket 0, bracket 1, etc. So what I'm going to do is I'm going to create a new array. Alright, so I've got an array now that is twice as big. And I'm just going to call this one, I'm going to call this array, I'll use this color here, temp. Okay, I need a variable name for it, right? So we'll call it temp. And remember, this variable is a reference, right? It's a reference pointing right here. But what I want to do first is I want to copy all of these values over. So I'm going to take this 8 and I'll just copy it right here. Then the -3, the 5, 17, and the 2. And these other values here will remain the default 0. I'll just leave them blank though for now. Now that I've copied those over, what I'm going to do is I'm going to change what array is pointing to. So in the memory of our computer, we have two different arrays, right? We have this array here that is the array we're using for our list, that the word array is pointing to, and then we've created another one called temp that's twice as big, and we've copied over all the elements of array from the beginning of that temp. Now I'm simply going to just remove this point here and change it to where it points to the same place that temp points to. So temp is pointing right here to the front of this. Make that clear. When we create the variable temp, we're creating a reference, because remember, an array is an object, it's a reference variable, so we're creating a reference to a specific spot in the memory, and array is now pointed to that same spot. We're just copying the reference that's in temp over to array. And then after that, well, I don't need this variable anymore. So it could be just a temporary variable. And voila, we have doubled the size of our array. So array.length, if we were to look at that and view it, its value would now be 10. Now I'm free to add another variable. So maybe this whole time, maybe I was trying to add a 9, and so we saw that it was filled up, so we doubled the size, and now I get to add a 9. And that's basically it. Well, what I want you to do is I want you to pause the video, and I want you to try and create this data structure. Java has lists already, so probably best if you avoid calling it something like list, or you've probably heard of Java's array list, but give it a name. I like to give mine names that are kind of backwards, like list array, or we're going to be using integers, so maybe call it int array, and go ahead and create this. But I want you to think about what our list should be able to do. I want right now just for you to be able to add to the back of our list, and I want you to make it to where you can get an item at a specific index in our list. Okay? So just try and do those two. What you don't want to do is give people methods to look at in your documentation that they don't really need to see. So the only methods that I want to be publicly viewable to users of this would be the constructor, the add method, and the get method. Any method you use for helping you do that, such as expanding the array, let's make those methods private. You've probably already learned about making private instance variables because we don't want our users having to look at that stuff. Let's make some of our methods private because we don't want our users having to see and plow through the methods that they should not be directly calling. So if it's not a method that you want someone from another class directly calling, keep it private so it doesn't cloud up the documentation. All right, so like I said, pause the video, give it your best shot, see how it works, and then we'll go over our answers together. Okay, well, I hope you had success making your integer lists. Let's see how I would do it. So I've got my BlueJ IDE open. I'm just going to call this int list because that's what ours is going to hold. All right. So public class int list. Now I need to have an array. So I'm going to make it an integer array because we're having int list, and I'll call it, I'll just call it array. And I also want a variable called size that I'm able to get the size of the list. All right, so when the int list constructor is called, we'll just create the array, and I'll start with a size of 5. And perhaps I should make a constant for that. That would probably be good habits. We'll make it a private int, and we'll call this private final int, I'll call it start capacity, or start cap. How's that sound? Start cap. There we go. And I'll make it equal to 5. Private. And I'm going to make it static. Private static final. That's a good way to do constants. So that when you make something a static, it means it will create that variable before the constructor is run. So this will be initialized. We won't have any problem where an instance variable hasn't actually been initialized to a value when we try and use it. So it's just a good habit to make that static. All right. Okay. Well, let's add public void add, and we're going to be adding a number to our list. Now, the first size, and we can make that explicit, when you don't, I did not say that size equals 0 when it starts, but it will automatically set that to 0, but it's a pretty good idea to explicitly state it in our constructor. So when we add to our array, when we have an array that is a list that's empty, our size is 0. Well, where should we be adding? What index should we be adding to? Well, we should be adding to the 0 index, right? So if we have a list of, say, 3 items, we're about to add a 4th, well, the 4th item is going to go in index 3 of the array. So if you think about it carefully enough, you're always adding to the index in your backing array of the value size. So that's what we're going to do. So, and we'll deal with how to make it expand in just a second, but I want to get this part out of the way. So we're going to be saying array bracket size is equal to the num. Then I will just simply increase size afterwards. Now, what would we do if we didn't have enough room? First of all, how would we know? Well, if we have an array of length 5 and our size is already 5, we can't add to index 5. The last index in an array is always one less than the length of that array. So if size is equal to the length of our array, we've got a problem. So I'm going to call a method that we're going to write called expand. Remember, to call a method inside a class, to call another method in a class from within a method, you just say the name of the method. But I'm going to make this method private. And I'll demonstrate how that looks on the documentation in just a minute, but that's going to be important. Okay, so again, just to make this clear, we're inside a method called add. To call another method in this same class that we're working on, just say the name of the method, expand. Okay, so how do I expand? Remember from the picture that we drew, we're going to create a new array, and I'll just call it temp, that's twice the size of the original one. The original array is array.length, and so I'll just multiply that by 2. Then I need to copy everything over, so I'll use a for loop. I less than, well, we could use array.length here. We could also just use size. We do need to be careful when you're using loops in an array list, because size and the array length are usually not the same. At this time they actually are, but I'm going to use size just because it makes me feel uncomfortable to say array length when I'm looping inside a list. All right, so I'm going to be copying over to index I elements in index I of array. So as I goes from 0 all the way up to, but not including the size of the array, it's just going to copy them over, and we're going to have a bunch of trailing zeros at the end. Now I simply change what array is pointing to. So right now the variable array is pointing to some location in the memory, and it's usually represented with a big hexadecimal number, right? It's a location. It's a memory address. And temp also has a memory address. So I'm simply going to say assign. Remember, this is the assignment variable, and we assignment operator, and we assign from right to left. I'm going to assign the memory address that's in temp over to the variable array. So we are now changing. Array is no longer pointing to the small array, it's now pointing to the bigger one, which is exactly what we want. And so after this method is done, it's going to return right back here. It only called this method if it needed to, and then it goes on and does that. Okay, super. I also wanted you to be able to access. So we'll be accessing a value. We'll have to return something to our user. Well, we'll be turning an integer in this case. An integer at an index in our list. We'll simply say return array bracket index. And that should work fine. All right, I know I didn't ask you to add this, but I think it'd be a good idea to, let's go ahead and add a size method so that people can get the size. Because if we're going to have them access something, they ought to be able to check if their index is reasonable. So public int, and it's usually called just size. You could call it get size if you want, but there we go. All right, we've got 3 public methods, okay? And I think that's going to be pretty good. So let's try it out. Okay, so I am going to simply use the BlueJ neat little workbench to create an object. Okay, int list1. All right, so very good. That sounds like a fine variable name to me. All right, so this is my int list. Let's figure out what we can do. Okay, so all right, here are the methods that are inherited from objects. So every class, subclass is the class object. So it's not surprising that we have these. Some of these would not really make sense to use, but others we might need to go ahead and override to make this more useful. Again, we'll save that for another lesson. Here are the 3 methods that I just made. These 2 are the ones I specifically asked you to do. Let's get the size. All right, it's 0. Cool. All right, let's add to our method. I want to add a 9. Okay. Now we'll get the size and size of 1. Let's add another one. Let's add a 3. Okay, and get the size, and it's a size 2. Super. All right. Well, I'll tell you what. This is, we're going to open up the hood now, and we're going to inspect the parts. So this is a important part of the BlueJ IDE is it allows us to inspect the objects that we've made to really see how they're working behind closed doors or under the hood. We wouldn't normally expect users to be able to do this, and they certainly couldn't unless they, had all of our source code. But I want to go ahead and do that to make sure we understand what's going on. Okay, so there are 2 variables, 2 instance variables that this object has. One is the size, and we've been accessing that. The other is this array that's making our list. Notice that it's a pointer, a reference. Let's inspect it. All right, this array has a length of 5. Okay, well that's because we set that to be the default value. You'll notice that we've added a 9 and a 3, and the rest are zeros. No big deal. But that's how that works. Let's go ahead and practice getting a value. Let's get the value at index 0. That's our 9. Perfect. You see int list1 dot get 0 return day 9. And that's how you would code this normally. You would say the name of the list dot get. Let's add a couple more, and let's check that our expand is working correctly. All right. And let's see here. Let me see how we're doing there. And now I gotta see here up to a 17. Let's add a little bit more. How about 88 and 99? Let's inspect it now. Okay, it's all full. So what I'm hoping happens is that when we create when we add one more int, I'm expecting to see this double in size, but otherwise behave perfectly normally to the user. So let's add a -3. That'll be an easy one to remember where we did this. Okay, we didn't get any errors, so that's good news, right? The size is now 6. Okay, good. So if the size is 6, that means the biggest index I can access is at 5. It's at -3. Perfect. So everything seems to be working really well from the user's perspective. That makes me happy. Let's go ahead and inspect it to make sure that we've programmed this exactly as we expect. All right, look at that. That's beautiful. We got 10 elements here from index 0 to 9. And everything looks to be working great. So we've successfully did that. Last thing I want to do before we shut down on this lesson is I want to look at the documentation. When you create the documentation, it's really easy to do so in BlueJ. You just go over here and just select documentation. That's one way to check how it works. You can also, mine's not coming up right now for some reason. You can also just go right here and say project documentation. And there it is. Okay, now it's working. All right, look at this. Is really neat. You can see exactly what we would give our users. You can see that they have add, get, and size. Those aren't all our methods, right? Because we kept one of the methods expand private. I don't want to have to burden them with a method that I don't want them calling directly anyway. I don't want them expanding just because they want to expand. That doesn't make any sense. That's a method that I use, not my users. All right, great. This all looks good. The only problem is there's absolutely no description on what these things do. Here's our constructor detail. That's not very helpful. That's not very helpful, right? How could we make these more helpful? Well, I'm going to go ahead and add some Java docs to just one of them, and then I'll leave it as an exercise to you to go back and do that yourself. So let's talk about the add. The way we make a Java doc is you put 2 asterisks after your line. And now we can make a description of what this method does. Adds to the back of this list. And we usually use the word this when we're doing something to an instance of a class, because that's the way the user is going to think about it. They've created a list and now they want to look at, oh, how do I add to it? They check this method. Oh, I see, it adds to the back of this list because that list is their list. And we're going to use an annotation at param because we take a parameter. So at param num, which is the integer or the int value to be added. And we're not returning anything, so I don't have to say at return. And there we go. Let's take a look at how that does. And I think it's not going to pull up this documentation here because I've got another thing with a parameter. It's expecting me to finish doing the Java doc before it works. So let's just do this. Yeah, regenerate it. Okay. And here we go. All right, got a little bit more description there. My method detail adds to the back of this list. Parameters num, the int value to be added. That's nice, professional. Good way to do it. So go ahead and try and add some more Java docs, and we'll meet in the next lesson and we'll talk about adding some more methods to this list.